Hello student, this is O.P.Yadav. Today now I am going to start what is the reciprocating unbalanced forces and their balancing. That is what balancing of reciprocating masses. Today I am going to start. So first I have taken balancing of this reciprocating IC engine, or we can say that reciprocating compressor. So first I am going to see that what are the unbalanced force, that is primary and the secondary unbalanced force. Then I will see that how to balance these unbalanced forces. Okay, so reciprocating unbalanced force for the reciprocating IC engine or reciprocating compressor. Okay, first let us understand. So this is the crank OA and this AB is the connecting rod. Its length is L. Length of the crank is a small r. And this is the piston or slider. And this is the N. N is equal to length of connecting rod upon length of the crank. So L divided by R is the N. So length of connecting rod to the length of crank rod. Okay. This crank is rotating with the constant angular velocity omega in this direction. At any state of time, this crank has moved at an angle of theta from this inner dead center. This is the inner dead center and this is the outer dead center. So at any time, this crank has moved through an angle of theta. Okay, at that time, this connecting rod is making an angle of phi with the line of stroke. So what are the unbalanced forces? So this can be proved that inertia force on the piston is the unbalanced force. Inertia force on the piston, say this is Fi. So that can be proved that inertia force on the reciprocating piston is the unbalanced force. That inertia force at the piston can be transferred because this is along the line of stroke. So that can be shown at any other point along their line of stroke, along their line of action. So that inertia force can be transferred here. So this is the inertia force, which is the unbalanced force. So F unbalanced force on the system is equal to inertia force. So we know that net force F is equal to m into acceleration of the piston. So inertia force Fi is equal to their mass into their acceleration. So acceleration of the piston is equal to r omega square cos theta plus cos 2 theta beta Tn plus something more. When we are expanding, we are getting a m number of term. We are neglecting the higher order term, then we are having only these two terms. So r omega square, this is the acceleration of piston and this is what the mass of reciprocating part. So unbalanced force becomes MRAC. RAC means what? Mass of reciprocating part. R, radius of the crank omega square cos theta plus cos 2 theta divided by n, and this n is equal to L divided by R. L is the length of connecting rod and this R is the radius of crank, length of crank. Acha, let us expand this. Then what we are getting? Mr omega square cos theta, then Mr omega square cos 2 theta divided by n. You look at here. So when theta is equal to 0, cos theta is equal to 1. When this theta is equal to 90 degree, then this cos theta is equal to 0. So what you are looking at, as the value of theta increases, the cos theta value decreases. Means what? This cos 2 theta is less than cos theta. Means the value of cos 2 theta is less and the value of cos theta is more. And the value of this cos theta is less. Another thing is that let us compare these two terms. So here is cos theta, this is cos 2 theta. Cos 2 theta is less and cos theta is more. I have given the value here. So this cos 2 theta is less, this cos theta is more. And also let us see that this term is divided by n, where n is equal to L bata k r. L is the length of connecting rod and r is the length of radius. Of course, this L is much greater than r. That is, this n is always greater than 1, much greater than 1. Generally, its value is 4 to 6. Generally, the value of n is 4 to 6. If this will be 4 to 6 means what? So you can see that this term is large and this one is very small. So this is very small and this one is this is very large and this is very small. Why this is small? Because cos 2 theta is less than cos theta, and also this term is divided by n, and thus n is much greater than 1. This is 4 to 6. So whole I want to say that this term is very large compared to this term. So this is very large. So we are saying this as a primary unbalance. This is the complete unbalance. So this part is the primary unbalanced force and this is the secondary unbalanced force. Primary and secondary. And the other higher term we have neglected. So that term can be neglected. When can be neglected? Let us see. And when cannot be neglected. When can be neglected and when cannot be. So I am neglected. So where I can neglect it? When the speed of the engine is small. Omega is small. Omega is small and n is equal to L divided by R is very small. If not very small, very large. So this is large. If n will be large, then this quantity will be small, then that can be neglected. So higher order term can be neglected when the speed of the engine is very small, or we can say the moderate, not the more than moderate, and the value of n is large, that is not very small, that is more than 3 to 4 value. Then we can neglect the higher order term if the speed of the engine is large or the value of n is very small, then higher order term cannot be neglected. You have to consider that term also for the balancing. Okay, so you have to mind it for the high speed engine. Also, you have to consider the other term and you balance that term also, that unbalanced force also. So for the low speed engine, we have considered this. So this is the primary unbalanced force and this is the secondary unbalanced force. Okay, so our primary unbalanced force is equal to m r omega square cos theta, and secondary unbalanced force is equal to m r, this m is the mrc, that is mass of reciprocating part. I am not writing repetitively. This cos 2 theta divided by n. So this is the primary unbalanced force and this is the secondary unbalanced force. Primary unbalanced force and the secondary unbalanced force. So this total net unbalanced force is classified into two parts. So both should be balanced. Okay, this both should be balanced. So let us balance. Now I am going to balance it. So balancing of primary. Let us balance the first primary. So balancing of primary unbalanced force. Balancing of primary unbalanced force. Balancing of this primary. So now I am going to balance this primary because this is more, this is less. So if the speed of engine is very small, also this can be neglected, but not for the high speed engine. First I am going to balance the primary unbalanced force, that is this mrc r omega square into cos theta. Let us see how this can be balanced. How this primary unbalanced force can be balanced. So what I am doing for that? So to balance this primary unbalanced force, that is what E unbalance is the inertia force. Now this primary unbalanced force is equal to m r omega square. I am not writing just to take here. I will write here. This primary unbalanced force, this is the primary unbalanced force, which value is equal to what? M r omega square into cos theta. How? First let us see that what we can imagine. So this primary unbalanced force can be assumed as, suppose we are assuming here a mass mrc. Here I am assuming a mass mrc, that is reciprocating mass. Let us assume that your reciprocating mass is concentrated at the crank pin. First let us assume, for balancing purpose, let us assume that this reciprocating mass is concentrated at the crank pin. So this is what mrc, this is rotating with an angular velocity of omega. So a centrifugal force will act radially outward is equal to what? M r omega square. That m and mrc is the same thing. So mrc r omega square. This is what the centrifugal force, unbalanced force. Now let us see that what will be component of this m r omega square along this. So that will be m r omega square cos theta. So this is what? This is similar to this primary unbalanced force. Means what? This primary unbalanced force can be imagined that the component of centrifugal force due to assumption of reciprocating mass at the crank pin. So this primary unbalanced force can be considered as component of unbalanced force due to centrifugal force on the reciprocating part, which is assumed to be concentrated at the crank pin. So this is what our imagination. This is what the imagination. Now, so if this is because of what, then this can be balanced. How this can be balanced? Just by the rotary method. So what you can do? You apply diametrically opposite a balancing mass. Suppose this is the balancing mass. B at a radius of what is small b. So this mass can be balanced. This assumed mass, imaginary mass, can be balanced by putting another balancing mass just radially outward, radially opposite, diametrically opposite. Let us say the balancing mass is capital B at a radius of a small b. Then what will be the centrifugal force on this? This will be capital B small b omega square. Let us resolve this component along this direction and along this direction. So if this angle is theta, this angle will be theta. If this angle is theta, what will be the value of this? This will be b omega square cos theta. And what about this? That will be sin theta. So this component will be bb omega square into sin theta, bb omega square. So component, this first can be resolved. This is the imagination, so I am not resolving this. This is actually, and that is the imagination. So, but this is the actually. So let us resolve this. So that component, if this is theta, that will be bb omega square cos theta, and this will be bb omega square sin theta. bb omega square sin theta. Okay. Let us see that. Now I want to balance this force completely. So for complete balancing, along the line of stroke. So unbalanced force was along the line of stroke, so I am balancing that completely. For complete balancing along the line of stroke, so you can see that this unbalanced force is in this direction, this primary unbalanced force is here, and this bb omega square cos theta is here. So this force can be balanced. So what I am getting from here, so this bb omega square cos theta is equal to this primary unbalanced force. This is what m r omega square cos theta. So m r omega square cos theta. So this cos theta has gone. This omega square has gone. So what I am getting, BB is equal to this m into r. This is what the reciprocating mass, mRc. So this BB is equal to mRc into r. So this is the condition for what? Complete balancing along the line of stroke. Along the line of stroke. This is the complete balancing along the line of stroke. But you are able to balance along the line of stroke. But let us see that this BB omega square sine theta is remaining. This is what? Unbalanced. This is what? Unbalanced. So you have balance along the line of stroke, but ये unbalanced force arises in the vertical direction, that is perpendicular to the line of stroke. So let us say this is what the vertical direction. So unbalanced force in the vertical direction is equal to this BB omega square sine theta. So you are balancing along the line of stroke, but a unbalanced force arises along what? Perpendicular to the line of stroke, that is in vertical plane. So this is what BB omega square sine theta. If you find out its maximum value, so if you see the maximum value, then what you are getting, the vertical unbalanced force की maximum value. So for maximum this sin theta is equal to 1. So you are getting this BB omega square. BB omega square. So what is the condition for that? Condition is that sin theta is equal to 1. For the maximum vertical unbalanced force, this sin theta should be 1. If the sin theta is equal to 1, means what? Theta is equal to 90 degree. So this will happen at 90 degree. Okay. Let us see. So this is the maximum value, and for complete balancing you have got that BB is equal to what? mRc into r. So let us put this value here. So what I am getting, mRc r into omega square. mRc r into omega square. Let us see what was the maximum value of this mr omega square cos theta, which is the primary unbalanced force. So its maximum value is what? mr omega square. That was what? In the along the line of stroke. And what is the maximum value of vertical unbalanced force after complete balancing? This is again m into r into omega square. Same value. So you have balanced completely along the line of stroke, but what is its reaction, anti-reaction? Yeah, what is its side effect? Its side effect is that you are getting a vertical unbalanced force perpendicular to the line of stroke. Perpendicular to the line of stroke means what? It's just direction has changes, but its magnitude is same. So just you have changed the direction of unbalanced force, but you have not balanced it. Okay. So this is a very dangerous. That vertical unbalanced force is very dangerous. If you are taking the case of what I said, a locomotive engine, then if that vertical force is very large, so that can lift the wheel. If the lift get lifted, then that will cause the accident of the train. जैसे आप सुने हो कि रेल पटरी से उतर गया मतलब क्या हुआ? That vertical unbalanced force is more than the static downward force due to their weight. If that will be more, then the train will be lifted and आप बोलोगे कि पटरी से उतर गया. Okay. So in the next lecture, due to that, so what we have seen that their direction have changed, but its magnitude is same. So in the next lecture, I will do the partial balancing of reciprocating IC engine. Partial means we will do the compromise. I will not balance completely this reciprocating part. Just I will balance some of them. So generally 2/3 of the reciprocating mass are balanced, or we can say that half to 3/4 part of the reciprocating mass are generally balanced. Means what? There will be some unbalanced force along the line of stroke. After the partial balancing, there will be some unbalanced force along the line of stroke, and also will be some unbalanced force along the perpendicular axis, that is along the vertical plane. So we are making the compromise, means we are dividing it. Just we are dividing कि something is in the horizontal and something is in the vertical. Just you are managing in different direction. Okay, that's why we are saying that complete balancing of reciprocating masses is not possible. Okay, thank you very much. In the next lecture, I will see the partial balancing of IC engine. Okay, thank you very much.